welcome to new session of the differential equation. In this session we will discuss about the linear first order differential equation that we are discussing the part 3 of the linear differential equation. We already discussed about the linear differential equation. Actually we know a first order linear differential equation is of the form y dash plus f of x into y is equal to r of x is a linear non-homogeneous differential equation. It is a linear non-homogeneous differential equation. See the y dash is actually dy by dx. Okay. So, in this case we discussed in the last two sessions, it is that we can find the general solution of this differential equation. We can find the general solution of the differential equation by using the formula the actually y into the integrating factor. It is equal to integral of r of x into integrating factor into dx plus c. Actually the integrating factor is actually it is that if is equal to integrating factor is equal to e raised to integral of f of x dx. Okay. We can find the integrating factor by using this formula. Here f of x and r of x are there. The f of x and r of x are the functions of x alone or the constants. So, in the last two sessions we did many problems based on this general formula and general first order linear differential equation is here. Based on that, by using this formula we did many problems. Now, see my dear students, here we discussed it is that the equation 1 is actually dy by dx plus f of x into y is equal to r of x. So, maybe sometimes the differential equation may exist in dx by dy plus g of y into x is equal to r of y. See the all terms just variables are changed. Here in this case we can say here this case the y is dependent. Y is dependent variable and the x, the variable x is the variable x is independent. The variable x is independent. So, here in this problem we just changed as x is dependent. X is a dependent variable and y is the independent variable. Y is the independent variable. Actually what we did it is that we just changed the capacity of the variables. We interchanged the independent and dependent variable in this problem. I would like to give this as the equation number 2. So, the thing is that we can just rearrange the variables. So, we just interchange the variables. Instead of y, here we will have x and there is an integrating factor is there and the function non-homogeneous parts function or variable constant is there. Instead of r of x we will have r of y and integrating factor is there and the instead of dx we will have dy. So, we have to find the integrating factor. So, in this case see my dear students, we will have dx by dy, we will have dx by dy, we will have dx divided by dy plus some g of y plus some g of y into x is equal to some r of y some r of y. This is actually our equation number 2. So, therefore, the corresponding general solution is the corresponding general solution is we can find the general solution by using the formula x into the integrating factor x into the integrating factor is equal to integral of r of y integral of r of y into integral of r of y into integrating factor into dx plus the constant of integration is there. Sorry, instead of dx, here we will have dy. dy is there. Okay, we have to find the integrating factor. So, we can find the integrating factor by using the formula integrating factor is equal to e raised to integral of g of y dy is there. E raised to integral of g of y dy is there. And we can just apply to this in this equation number 3. We will get the general solution of the differential equation 2. Okay, we can move to the question. Solve the linear differential equation. Solve the linear differential equation. Solve the first order linear ODE. Solve the first order linear ODE. Y dx minus of x plus 2y square minus of x plus 2y square dy is equal to 0. dy is equal to 0. So, put this as equation number 1. Say y dx minus of x plus 2y square dy is equal to 0. Okay, I would like to rewrite this as y dx is equal to, I would like to take this is to RHS, therefore, we will have minus of x plus 2y square dy is there. Here it will be x plus 2y square dy is here. Okay, fine. Now, I would like to take this dy to here, dx by dy will be there. I would like to take this y to RHS. So, we will have dx divided by dy is equal to x plus 2y square whole divided by y is there. X plus 2y square whole divided by y is there. Now, it is okay, fine, we can have this is equal to dx divided by dy, dx divided by dy, okay, is equal to x by y, that is equal to we can write this as 1 by y into x, fine, and 2y square by y, that is actually 2y plus 2y is there. Okay, fine. Okay, we found it. We will have this is equal to 2y square by y is equal to just 2y is there. Okay. Now, we have dx divided by dy minus 1 by y into x is equal to 2y. This is our new equation, that is the equation number 2 here. Okay. See, we can compare. Well, comparing to general form, we will have here dx by dy is there, some g of y is there, x is there, r of y is there. See, here we will have dx by dy is here. Instead of g of y, we will have here this is the g of y. Okay. And here we have this is the r of y. Fine. Okay, now we need to find the integrating factor. We have the formula, it is that x into we can find the general solution by using the formula x into integrating factor is equal to integral of r of y into integrating factor into dy plus the constant of integration is there. So, to use this formula to find the general solution, we have to find the integrating factor. So, we will find the integrating factor. To find integrating factor, IF is equal to e raised to integral of g of y dy, e raised to integral of g of y dy. We just come back, we will have g of y is minus 1 by y. So, we have this is equal to e raised to integral of minus 1 by y dy, minus 1 by y dy. Okay. So, we will have here it is equal to e raised to integral of integral of minus 1 minus integral of 1 by y is equal to log mod y, that is equal to log y. So, we can write this as this is equal to e raised to log of y raised to log of y raised to minus 1. E is there and log is there. So, as according to that we discussed in previous classes, we can say the e and log will go on, and finally, we will have here it is equal to y raised to minus 1 is there. That is y raised to minus 1, that is equal to 1 by y is there, y raised to minus 1 equal to 1 by y, y raised to minus 1, y raised to minus 1 is there, that is equal to y raised to minus 1 is there, this is equal to y raised to minus 1 is equal to, that is equal to 1 by y is there. So, actually integrating factor is 1 by y. So, we found the integrating factor. Therefore, the integrating factor is equal to 1 by y. Put in equation number 2. Put in 2. Just come back to equation number 2. What is actually equation number 2 is x into integrating factor is equal to r of y into integrating factor into dy. So, we have the equation general solution is here, x into integrating factor is equal to integral of r of y into integrating factor into dy plus the constant of integration is there. See, x into the integrating factor is 1 by y is equal to integral of r of y is actually 2y. So, this is actually equation number 3, r of y is actually 2y, therefore, we will we put r of y is actually 2y, this is equation number 3, r of this is equal to 2y into 1 by y dy plus the constant of integration c is there. So, we will have x by y is equal to, we have 2y and 2y, y and y we can cancel it. Therefore, integral of 2 dy plus the constant of integration is there. So, this is actually x by y is equal to 2 into integral of 2 into dy, that is equal to 2y plus the constant of integration c is there. Therefore, we have this constant of integration c is there. So, we can take this y to here and this y to here. Therefore, x is equal to 2y square plus cy is the general solution. Is the general solution of given differential equation. Given differential equation is the general solution of given differential equation. See, we found general solution, that is a general solution in x and y. Okay, general solution in x and y. So, this is actually we just interchanged dependent and independent variable. The dependent variable y is interchanged with the x and x is interchanged with the y. So, we can find by using this formula, the equation number 3, we can find the general solution, and we can find the integrating factor by using this formula. Okay, fine. This is the method that we can find by using if we interchange or replace the independent and dependent variable. Okay, we can just move to another question of the linear differential equation. So, find the equation of curve passing through the point. Find the equation of curve. Find the equation of curve passing through passing through 0 1, passing through 0 1 is the tangent to the curve at any point, is the tangent to the curve at any point x y, at any point x y is equal to, if the tangent to the curve at any point, if the tangent to the curve at any point x y is equal to sum of the x coordinate, is equal to sum of the x coordinate and the product of the sum of the x coordinate and the product of the x coordinate and y coordinate, and the product of the x coordinate and y coordinate, product of the x coordinate and y coordinate. So, actually we need to find an equation of curve, that equation of curve passing through the point 0 1, that equation of curve passing through the point 0 1. Okay, the tangent to the curve, at any point is the sum of the x coordinate and the product of the x coordinate and y coordinate. Okay. So, we can so we have to find the equation of the curve. See, my dear students, we just trying the curve is passing through, curve passes through 0 1, curve passes through 0 1. Okay, fine, curve passes through 0 1, and the slope of the tangent to the curve, slope of the tangent to the curve is actually this is slope of the tangent to the curve is dy by dx is equal to sum of the x coordinate and the product of the x coordinate and y coordinate. Okay, passing through the point and tangent to the curve is passes through that. Okay, dy by dx is equal to x plus xy. See, my dear students, this can be written as this, we will take xy to here. So, dy by dx minus xy is equal to x. So, see, I would like to put this is equation number 1 in this case, and see, my dear students, while evaluating this problem, you will feel that the equation 1 is actually linear first order ODE, ordinary differential equation. Dy by dx is there, instead of f of x the value minus x is there, instead of f of x the value minus x is there, instead of r of x the value x is there, the function x is there. See, and we are given that is passes to 0 1. because it is passes through 0 1, the x value whenever x is 0, the y is equal to 1. So, we can say that this is actually the equation 1 is actually dy by dx, the equation 1 is actually dy by dx, dy by dx, okay, dy by dx minus xy is equal to x minus xy is equal to x, and also we can write this is y of 0 equal to 1, y of 0 equal to 1. That means, whenever x is equal to 0, y is equal to 1. See, from here we can say that when x is equal to 0, then y is equal to 1. Whenever x is equal to 0, then y is equal to 1. Okay, fine. So, like that we can say that whenever x is equal to 0, y is equal to 0, 1. So, actually this is equation 2 as a given differential equation is a initial value problem. So, actually this is initial value problem. So, we can find a particular solution that will be after evaluating this differential equation while applying this initial condition, we will get a curve. That curve is a particular curve, that curve is the solution of the differential equation. That particular curve should pass us through 0 1. Okay, so we can solve this is, and while solving this we will have the general solution is to find general solution. We use the formula y into integrating factor is equal to integral of integrating factor into r of x dx plus the constant of integration c is there. So, we can put this is equation number 3. We have to find the integrating factor. To find integrating factor, we have the formula if is equal to e raised to integral of f of x dx is here. Okay, actually the formula we have the formula e raised to integral f of x dx is there. The f of x is actually minus x. Okay, this is actually f of x. This is equal to minus x is f of x. This is r of x. Okay, so we have f of x minus x is there. So, this is equal to e raised to integral of minus x dx is here. E raised to integral of minus x dx is there. So, we will have e raised to integral of minus x is equal to e raised to minus of integral of x is x square by 2. Okay, we found the integrating factor. The integrating factor is actually e raised to minus x square by 2. Okay, fine. So, we can put in 3. We have the equation 3 is here. Y into integrating factor is equal to integral of integrating factor into r of x dx plus c. So, we can write this as therefore, the general solution is. So, therefore, general solution can find by using, we can find the general solution by using y into the integrating factor. The integrating factor is actually e raised to minus x square by 2, e raised to minus x square divided by 2 is equal to integral of r of x into e raised to minus x square by 2 plus x square by 2 dx plus the constant of integration c is there. Okay, fine. So, we can find the integral part, that is equal to I is equal to we have x into e raised to minus x square by 2 dx. Okay, I would like to put u is equal to minus x square by 2. Okay, therefore, this implies we can differentiate d is equal to minus du is equal to minus 2x dx divided by 2, minus 2x dx divided by 2. Okay. So, finally, we will have du is equal to. So, we have minus du is equal to, from here we have, therefore, minus du is equal to x dx, minus du is equal to x dx. So, instead of e raised to minus x square by 2, we can write e raised to u. Instead of x dx, we can write minus du. Therefore, I is equal to, 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 we can write this as I is equal to e raised to minus x square by 2 e raised to u minus du. So, minus integral of e raised to u du. Okay. So, we can write this as minus e raised to u itself. Therefore, we can replace this is equal to minus e raised to minus x square by 2. That is actually the I. Okay, fine. So, we can replace that value in our solution here. I would like to put this as equation number 4. So, actually this is I, this integral, sorry, this integral part is I. So, we can replace I there. So, we will have, therefore, y into, therefore, put in 4, therefore, we will have y into e raised to minus x square by 2 is equal to integral of e raised to, sorry, instead of integral we found the value as e raised to minus x square by 2 plus the constant of integration is there, plus the constant of integration is there. So, we can just replace this minus x square by 2 from here. So, we will have e raised to minus x square by 2 divided by e raised to minus x square by 2 will have, therefore, y is equal to, therefore, y is equal to e raised to minus x square by 2 plus, divided by e raised to minus x square by 2. This will be cancelled, the value will be 1, and c divided by e raised to minus x square by 2 is there, that we will take into numerator. Therefore, we will have c e raised to x square by 2. Since the e raised to x minus x square by 2 in denominator is there, that we taken into numerator. Fine. And one more thing it is that, yes, here we will have e raised to minus x square by 2. Therefore, here we will have, sorry, minus sign is there. So, we have here minus 1 is here. So, this is actually the general solution. Is the general solution given differential equation, but actually we need to find the curve passing through 0 1. So, apply the initial condition. To get the actual curve, to get a required curve, apply the initial condition in phi. Apply the initial condition in phi. Initial condition in phi. We will apply the initial condition in phi. So, while applying, that is the initial condition, we know the initial condition is that whenever x is equal to 0, then y is equal to 1. That is y is equal to 1 when x is equal to 0. that is y is equal to 1 when x is equal to 0. So, we have this is equal to y is equal to 1 when x is equal to 0. Therefore, we will have the y value is equal to 1 is equal to minus 1 plus c e raised to x square by 2, x is actually 0. Therefore, e raised to 0 is there. Therefore, we can take this minus 1 to here. Therefore, c will be equal to minus 1 plus 1, c raised to 0 equal to 1. So, c is actually equal to 2. Therefore, we will have actually therefore, the required curve is actually y is equal to this one instead of c, the 2 e raised to x square by 2, c e raised to x square by 2, c e raised to x square by 2 minus 1 is there. So, this is the actual required curve that we demanded our question. So, that is all about this linear differential equation. This is what we discussed in last question is that normally we discussed in our previous parts itself, but the that is a new way of the finding the curve by using the differential equation. Okay, my dear students, write down some questions for working out assignments. Solve linear ODE, solve linear ODE, dy by dx plus 2y is equal to sin x, dy by dx plus 2y is equal to sin x. The second question is solve 1 plus x square dy, 1 plus x square dy plus 2xy dx plus 2xy dx is equal to cot x dx, is equal to cot x dx, is equal to cot x dx, where x not equal to 0, where x not equal to 0, cot x dx where x not equal to 0. Okay, you can find many questions in the many different textbooks of the differential equation. There are many textbooks written by different authors about the differential equation, that are all nice books. You can find out many questions related to linear differential equation that you can do. Okay, thank you for watching this video. Continue your watching. Thank you very much.